Welcome back to The Explainer, everyone. Today, we're diving into something truly bizarre that recently went down in our solar system. Back on August 5th, 2026, a massive, essentially rogue piece of human-made space hardware slammed directly into the moon. I mean, it sounds like something straight out of a sci-fi movie, right? But it's entirely real. And as you'll see, it actually opens up this fascinating window into orbital physics, the history of lunar impacts, and honestly, the future footprint humanity is leaving beyond Earth.
So, picture this. What actually happens when 4 tons of human hardware slams into the moon at 5,400 miles per hour? It's a jaw-dropping question. When the news first broke that a SpaceX Falcon 9 upper stage was literally on a collision course with the lunar surface, the internet absolutely lost its mind with wild speculation. So let's just bust a major myth right off the bat here. This was definitely not a missile attack, and no, SpaceX didn't intentionally bomb the moon. What we're looking at is a purely accidental impact. It was just a discarded rocket stage left over from a completely routine mission that, well, happened to find itself on a one-way trip to the lunar surface.
Okay, let's take a quick look at our investigation roadmap for today. We'll start with 1, the accidental moon crash, then 2, anatomy of the impact, followed by 3, a lucky break for science, and finally 4, the lunar trash problem. Let's just jump right in.
Starting off with Section 1, the accidental moon crash. Now, the sheer speed involved here is just staggering. When this discarded upper stage of the Falcon 9 finally made contact near the Einstein and Bell craters, it was traveling at roughly 5,400 miles per hour. That's about 8,700 kilometers per hour, or roughly 2.4 kilometers every single second. Just try to imagine a piece of hardware roughly the size of a school bus absolutely booking it at those velocities.
And you know, it wasn't just fast, it was incredibly heavy. We're talking about 4 metric tons. That's 4,000 kilograms of artificial hardware. When you take that much mass and you combine it with the speed of 5,400 miles per hour, you get an absolutely immense, mind-boggling transfer of kinetic energy the second it hits.
So how exactly did it get there in the first place? Well, let's rewind a bit to over a year prior. In January 2025, SpaceX launched the Falcon 9 from the Kennedy Space Center, and it was carrying Firefly Aerospace's Blue Ghost Mission 1 toward the moon. Now, that payload landed perfectly in March 2025. Usually, rocket stages that finish their jobs in Earth orbit just fall back down and burn up harmlessly in our atmosphere. But because this specific mission had to push its payload all the way toward the moon, the upper stage got sent deep into space. It couldn't just easily fall back to Earth. So after it did its job, it simply became this dead, uncontrolled object floating out there.
Which brings us to Section 2, anatomy of the impact.
You might be wondering, why did it hit the moon instead of just, floating away harmlessly into the void? Well, space isn't just a place where things travel in straight, predictable lines forever. Once this upper stage ran out of juice and lost the ability to perform controlled maneuvers, orbital physics completely took the wheel. Its path became a chaotic dance entirely dictated by the gravitational pulls of the Earth, the Moon, and the Sun, plus its own momentum. And get this, even solar activity played a part. Over time, independent astronomers watching this thing realized it was getting pulled right toward the moon, and NASA eventually confirmed there was a 100% probability of impact. No avoiding it.
Now, what's really interesting here is the difference between an impact on Earth versus one on the moon. A lot of people were asking online, was there a massive explosion? Actually, scratch that. There was no explosion at all. There was no explosive payload, no warhead. If this thing hit Earth's atmosphere at that speed, aerodynamic heating would have caused a massive atmospheric shockwave, burning it to a crisp. But the moon? Zero atmosphere, no shield. So the rocket didn't burn up. Instead, all that massive kinetic energy was instantly transferred right into the lunar rock. It was a violent, sudden stop that vaporized and melted material instantly, throwing up this massive, spectacular cloud of dust and debris that we call an ejecta plume.
And of course, slamming 4 tons of metal into the ground is definitely going to leave a mark. NASA estimated it dug out a crater roughly 60 feet wide and 12 feet deep, while independent scientific modeling suggested it might be closer to a 40-meter diameter. But to put this into perspective, right? Compared to the thousands of absolutely massive natural impact craters covering the moon, this new little crater is a tiny, tiny scratch. It didn't split the moon in half, it didn't alter its orbit one bit, and Earth was literally never in any danger. On a lunar scale, it's barely even noticeable.
And that scratch brings us to Section 3, a lucky break for science.
What started out as a completely bizarre accident quickly turned into an absolute gold mine for science. Astronomers were incredibly hyped about this. One researcher called it a perfectly controlled natural experiment. And that phrase just hits the nail on the head. You see, the moon is getting pelted by space debris all the time. In fact, NASA says a natural meteoroid with roughly the same impact energy as this rocket stage smacks into the moon about once every 6 days. But the huge difference here? Scientists actually knew this one was coming. They could predict it, prep their instruments, and treat the whole thing like a massive, free laboratory experiment.
So the absolute game changer here is that with natural meteoroids, researchers are always kind of guessing the initial stats. They don't know exactly how heavy or fast the rock was before it hit. But with this rocket, they knew the exact origin of the object. They had tracked its trajectory for months. They knew its approximate mass down to the kilogram, and they knew its exact impact speed of 5,400 miles per hour. By taking all those perfectly known variables, plugging them into their computer models, and then comparing the math with the actual crater it made, scientists can vastly improve our understanding of impact physics and lunar geology. It's like having the answer key to a really complex test.
And man, the data started pouring in almost immediately. Even though we couldn't see the crash with the naked eye from down here on Earth, some of our most powerful instruments were glued to the spot. The European Southern Observatory's very large telescope down in Chile actually picked up spectral signatures of sodium, which was likely the vaporized lunar soil, and lithium, which very well could have been from the rocket's own battery materials vaporizing. On top of that, South Korea's Danri lunar orbiter was in the perfect position to snap these incredibly valuable before and after photos of the impact zone from orbit. We got data that Earth-based telescopes simply could never reach.
Now, as wild and unique as this whole event feels, it's actually part of a growing trend. This wasn't the first piece of human hardware to smack into the moon, not even close. Back in the Apollo era, NASA intentionally crashed parts of the massive Saturn V launch system into the surface just so they could study the resulting seismic activity. Then in 2009, the LCROS mission deliberately impacted the surface to search for hidden water. And there are accidental precedents too, like a Chinese rocket stage that hit the moon in 2022, not to mention all the various robotic landers that have unfortunately crashed during descent over the years. We've kind of been leaving our mark up there for decades.
Which naturally leads us to our final section, Section 4, the lunar trash problem.
We really need to zoom out from just this single SpaceX event and look at the bigger picture here, the impending crisis of space debris. The space around our moon is about to get incredibly crowded. We've got NASA's Artemis program gearing up for sustained human presence. Commercial companies are building and launching new lunar landers at a rapid pace, and global space programs from countries like China, India, and Japan are heavily expanding their lunar missions. Now, more spacecraft inevitably means more inactive, leftover junk. An uncontrolled 4-ton rocket might just be a cool science experiment today, but in a crowded lunar orbit, that becomes a massive operational nightmare. It could easily destroy an active billion-dollar spacecraft or threaten future research bases on the ground.
So, because of this escalating risk, mitigation just isn't optional anymore. We can't just cross our fingers and hope for the best. Reports show that NASA and SpaceX are already having deep discussions on how to prevent this exact scenario from happening again. And the solution really comes down to designing every single mission with deliberate end-of-mission plans. That means we have to engineer spacecraft to use controlled trajectories, making sure they either burn up back at Earth or intentionally miss critical lunar areas. Or we have to park inactive hardware into designated safe disposal orbits well out of the way so they never unexpectedly cross paths with future lunar missions. At the end of the day, this SpaceX rocket crash might have been a total accident, but it serves as a massive wake-up call for all of us. For billions of years, the moon has been quietly bombarded by natural asteroids and comets. But now, for the very first time in history, our own technology is becoming a permanent part of that ancient impact record. As humanity prepares to actually build a lasting, sustainable presence in deep space, we really have to ask ourselves, getting to the moon is clearly only part of the challenge. How are we going to manage what we leave behind? Thank you so much for joining me for this explainer, and I'll catch you in the next one.